Welcome back to Low Stress Math with Mrs. Bono. We are in Book 1, Algebra Prep, and we are just getting started. Okay, the first chapter is 0, the real number system. And as you know, that is pi 3.141592653, blah, blah, blah. I don't think everyone can fit, ha, ha, ha. No one can fit because pi goes on forever and even a selfie can't get everybody. So let's take a look at the warm-up. If you haven't done the warm-up, I suggest you do it. Just take a minute, pause the video, and warm up a little. The first lesson, lesson 1, is going to be about numbers and number systems. So let's take a look at this first one. List at least 3 ways you use numbers every day. That's you. That's on you, boo. You can list as many ways as you know. Me, personally, I'm going to write down that I woke up this morning to a clock. So that was time. And with time, I'm going to also put date, because I know today's date. And then I went downstairs. I had to make myself some coffee, so I had to use a measuring cup. So I measured with a cup. And then after I had my lovely cup of coffee, I went outside, I got into my car, and I put my car in drive, and I watched the speedometer. And that's how I knew how fast I was going to come to school. Now, of course, you know, I did not speed. All right, the next page. You could have any answers you want in there. Write about your locker and the combination and how hard that was to do, or whatever, using the room number to get into the room. Whatever your numbers were, write about them. Okay. Lesson 1, the real number system and sets of numbers. Now, the real number system is both rational and irrational. And that's real numbers. That gives you the question of, are there any fake numbers? Well, sort of. There's imaginary numbers, but they're not really fake. Examples of rational numbers include integers, whole numbers, natural numbers, and irrational numbers. So in my mind, rational numbers are numbers that make sense to me. So what am I talking about there? What kind of numbers make sense to me? Well, if I'm counting something, that makes sense. Or if I'm, say, buying something and I have to use $2.72, that's a rational number. It makes sense to me. Having half a bottle of water left for the afternoon, that makes sense for me. But numbers like pi, that first page, that's not really a sensible number. It's a necessary number and it's useful in a lot of ways. You can't picture it so easily. So these are easy numbers, the ones that are easy to picture. Now I'm going to start with natural numbers. I'm going to start in the beginning and work my way out. Now, natural numbers are all the counting numbers. Starting with, well, think about a little kid. If you ask a little kid to count to you, they're all going to start the same way. 1, 2, 3, but then they get lost in the trees and they'll like skip to 17. But you know, they usually can start with 1, because that's how it's natural to start with 1. All right, so for example, now I'm going to do what's called a set notation. And you use a curly bracket for that. What's a curly bracket? Well, it looks like a C and an arrow and another C. That's a curly bracket. And counting numbers are 1, 2, 3, 4, whatever. And then I'm going to use a little ellipses. That means it goes on and on and on forever and ever and ever. Then I can close that with a end of a curly bracket, backward C, an arrow, and a backward C. But if you just put a squiggle, I'll know you mean a curly bracket. Whole numbers. Whole numbers include all of the natural numbers, because this whole circle is inside the bigger circle. So whole numbers are all of the natural numbers And then just to give me a little reminder, that's counting. And 0. That's the only difference between natural numbers and whole numbers, is a 0 in the middle. Oh wait, look, in the middle of the whole, there's a 0. Yes, and a whole has nothing. Forget it, Bono, you're useless. Here we go. I'm going to make a curly bracket and start with 0, 1, 2, 3, and then dot, 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 because it keeps going, and close my curly bracket. All right, integers. So look what's inside the integers. The whole numbers are inside the integer circle. So all of the whole numbers are integers. So all of the whole numbers, including negative whole numbers. So all of the whole numbers, that's the counting numbers plus 0. Numbers, including their opposites. So the opposite of the counting numbers. I'm going to start with a curly bracket and put dot, dot, dot. And it's -4, -3, -2, -1. Don't forget the 0 in the middle and the rest of the whole numbers that are positive. And dot, dot, dot to the curly bracket. Don't forget those commas. That's what separates the number and makes it 1, 2, 3 instead of 123. All right. Now, rational numbers. That's all of these numbers. It's all the natural numbers, 0, negative natural numbers, plus things that make sense, like 3/5, or 1/2, or 1.375, or 2.6, or 3.56. Any number that terminates, which means it has an end, or repeats, like 0.33333, those numbers are all rational. We will get back to rational in a little bit. So, all of the above, including fractions and repeating or terminating decimals. Repeating and terminating decimals. Okay, so let's do like dot, 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 -3.25, and say -2.5, and say -3/2. All of those are rational numbers. So is 0. So is 1, so is 2, all the numbers that are going to make sense, all the rational numbers. So is 7/3. Those are all rational numbers. Oh, look at me, I made a mistake already. Get my white out. Love my white out. Here we go. Dot, 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 because there's more numbers. Keeps going on forever. All right. So, irrational numbers, non-repeating, non-terminating decimals. Yeah, what does that mean? Well, let's take a look at what a not repeating, not terminating decimal is. Those are usually square. Do you remember square roots? All right, let's take a look at some square roots. So if I do second x squared, I get this little check mark looking thing called a square root. And if I put a 9 in and hit enter, I get the whole number 3. But what happens if I do second square root of 10? Now, it didn't change. If I press the double arrows, it's going to be a number, and it's going to go on and on and on and on and on, and it's never going to end, and it's never going to repeat. Non-repeating does not repeat. Non-terminating does not end numbers. So non-repeating, non-terminating decimal numbers. So, for example, negative square root of 2, say the square root of 3, let's do pi. Pi does not repeat, it does not end. E is another number that does not repeat, does not end. I'm just going to put a little bracket around all those kind of numbers that are just never ending, never repeating. Real numbers are all the rational numbers and irrational numbers. What did I did something wrong. I didn't put a dot over my irrational. Oh, well, that's okay. So let's keep going with this. Here we go. Look at, we're all the way on page 6. Here we go. Now, this is practice. You need to stop, take a minute, look back on the page before, and you're going to put these numbers where they belong. So place the letter of each value in its location in the real number system below. So for instance, the number 7. You can count to the number 7. That's a natural thing to do. I'm going to put that A, 7 goes here. B, negative 36 over 12. Well, let's take a look at what that is. Negative fraction, can you see? I hope you can see. 36 down Bono over 12. I believe that's negative 3. Yes. And negative 3 is an integer. It's a negative natural number. So I'm going to put B, negative 36 over 12 in the integers, because when I reduce it to lowest terms, it becomes an integer. Let's take a look at negative 36. So put the negative in, and now to get a square root, you're going to hit this green button and x squared, and then put the 36 in there. Let's see what happens. Negative 6. Well, that's a rational number. That's an integer, because you can't, that's the negative of a whole number, negative 36. But when I put C in here, I'm going to put negative square root of 36. Pi. Pi is definitely irrational. Don't know what it is. 6.48. If I think about that as money, as $6.48, that is definitely rational. It's not an integer because it has a decimal, but E, 6 48/100. F is negative 2, which is also an integer. G, negative square root of 10. Oof, that's irrational. You could do that on your calculator if you want. H, 0. 0 is a whole number. You can start counting from 0. 2 1/6. Well, that's a rational number. Anything with a fraction is rational. Ooh, I forgot to put the letters by these. Darn it, Bono. H is 0. And pi was D. And negative square root of 10 is G. That's better. Oh, look, this is a repeating decimal. Repeating decimals are rational. J is negative 0 7/10. That's a rational number. Okay, now this whole hot mess I have to put in here. So let's do that. The second square root. Now, in the second square root, I'm going to put a fraction. So n over d, 4 on the top, 81 on the bottom. And when I hit enter, look, it becomes the nice fraction 2 over 9. Well, the nice fraction 2 over 9 is rational. So I'm going to put the square root, letter K, square root of 4 over 81. So as long as you can put it in the calculator and it becomes a rational number or an integer or a whole number or a natural number, then you can say that that's a real number in the rational, integer, whole, or natural. Irrational, if I put pi in here, which there is a pi button on our calculator, here's pi, and if I hit double arrows and enter, it comes up as 3.14159, blah, 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 blah. Or if I put that negative square root of 10 in, oh, I did that wrong, darn it, delete. Square root of 10. Remember, that's also going to be irrational. Oh, syntax error. Oh dear. Dear, oh dear, oh dear. I don't want that. What am I doing here? I don't even know, Bono. Here we go. And double arrows, negative 3.16. Ugh, just keeps going. That's definitely irrational. Which expression does not name an integer? Not is important. And integers are whole numbers. Negative 15 is a negative whole number. 0 is a whole number. 6/14 is rational, but it's not an integer. And 12 divided by 6 equals 2. So that is an integer. So the answer is B. Which expression represents an irrational number? Okay, repeating is rational, fractional rational, square root of 75. Well, let's see what that is. Zip, second square root 75. And that is, oh, it changed to 5 square root of 3. And if I hit the double arrow key, it just keeps going on and on and on forever. That is irrational. Well, let's check this one too. Second square root 3. Get off of it using the arrow, minus second square root 3, and you get 0. 0 is a rational whole number, so that one's fine. So it's just this silly one here. Which number is not a whole number? Oh, 18 divided by 3 is 6, and 6 is a whole number. But negative 10 is an integer. Be careful. Which of the following is a true statement? Negative 9 is a whole number. Well, that's not true. Square root of 25 is irrational. That's not true. The square root of 25 is 5. 0 is a natural number. That's not true. 2/3 is a rational number. That is true. Okay. Which of the following statements is false? False. All real numbers are rational. That's not true. Some real numbers are irrational. All natural numbers are integers. Well, here's the integer circle, and the natural numbers are inside it, so that's true. All natural numbers are integers. So, all real numbers are rational. That's false. This is true. Every whole number is a real number. That's true. Every integer is a rational number. That's true. The only one that's not true is all real numbers are rational, because some real numbers are irrational. Give an example of a number that's a whole number but not a natural number. Well, the only one that's a whole number but not rational is 0. Give an example of a real number that is not rational. A real number that's not rational. An irrational number. If it's real and it's not rational, it's irrational. Let's use pi. Pi is irrational. Give an example of a rational number that's not an integer. Well, anything that's a fraction is going to be rational but not an integer. So like 2/3. And anything that's a decimal that does not repeat and that repeats or ends, like negative 0.7, that has a term in it that ends, or 0.3 repeating, those are all rational numbers. Okay, let's take a look at your homework for tonight. Oh, good, look at that. Independent Practice, Lesson 1, page 7. And if you're not sure how to do something, you can scan the QR code and watch this YouTube video. Good luck, and I will talk to you soon.